Hello friends, hope you are doing great. Today we will discuss about the first 20 elements of the periodic table, right? So here I am writing the atomic number or the serial number, right? It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So here I have written the serial numbers for the first 20 elements, right, from 1 to 20, right. Now the symbol, the symbol of element. So atomic number 1, the element is hydrogen and the symbol is H. Atomic number 2, serial number 2 is helium. Third is lithium. Fourth is beryllium. Fifth is boron. Sixth is carbon. Seventh is nitrogen. Eighth is oxygen. 10th is fluorine. Sorry, ninth is fluorine. And 10th is neon. Right? 11th, atomic number 11 is sodium. 12 is magnesium, right? 13th is aluminium. 14th silicon. 15th phosphorus. 16th sulfur. 17th is chlorine. 18th is argon. 19th is potassium and 20th is calcium. So friends, here I have written the symbols of the first 20 elements. Now you should help me write their names also. So what is the name of the element? Yes, who can tell me the name of the element, right? So atomic number 1 or serial number 1 is H. H stands for hydrogen. Hydrogen, right? The name of the element is hydrogen. Then second is He. So what is He? He is helium. He is helium, right? The third is Li. Li stands for lithium. Lithium, right? Fourth is Be. Be stands for beryllium. Beryllium, right? Fifth, atomic number 5 is B. B stands for boron, right? Atomic number 6 or serial number 6 is C. C for carbon, right? Carbon. Then seventh is N. N for nitrogen, right? Eighth, atomic number 8, serial number 8 is oxygen. O for oxygen, right friends? Then atomic number 9 is F. F for fluorine. F for fluorine, right? Then 10, it is Ne. Ne is the neon. Got it? Then serial number 11. Who can tell me? Who can tell me serial number 11? Na. What is Na? Na is the Latin name for sodium. Latin name for sodium. Can you tell me the Latin name? The Latin name is natrium. Natrium is the Latin name for sodium. So the symbol is Na, right? Mg. It stands for magnesium. Mg is magnesium. Then serial number 13, atomic number 13 is aluminium. It stands, the symbol is A small l. Atomic number 14, it is silicon. Silicon is Si. Atomic number 15 is phosphorus. Phosphorus is, the symbol is P. Atomic number 16 is sulfur. The symbol is S. Atomic number 17 is chlorine. Chlorine, the symbol is Cl. Atomic number 18, it is argon. The symbol is Ar. Atomic number 19, it is potassium. So what is the symbol for potassium? The symbol for potassium is K. So why K? K is actually kalium, which is the Latin name again for potassium. Kalium. So the symbol is K. And atomic number 20 is calcium. It is calcium, right? So atomic number 1 is hydrogen, atomic number 2 is helium, atomic number 3 is lithium, atomic number 4 is beryllium, atomic number 5 is boron, atomic number 6 is carbon, atomic number 7 is nitrogen, atomic number 8 is oxygen, atomic number 9 is fluorine, atomic number 10 is neon, atomic number 11 is sodium, atomic number 12 is magnesium, atomic number 13 is aluminium, atomic number 14 is silicon, atomic number 15 is phosphorus, atomic number 16 is sulfur, atomic number 17 is chlorine, atomic number 18 is argon, atomic number 19 is potassium, and atomic number 20 is calcium, which is Ca. Right, friends? So this was about the atomic number, the symbol and the name of the element. Let us quickly now look at the electronic configuration. Electronic configuration, which stands for the distribution of electrons. Distribution of electrons. So you know that we have a K shell, L shell, M shell, and N shell. So this one electron of hydrogen, it will go to the K shell, right? 2 electrons of helium will go to the K shell again. Now lithium, it has 3 electrons. So the maximum capacity of this shell is 2 electrons only. So the third electron will go to the L shell. Right? Similarly, for beryllium it will be 2, 2. For boron, can you tell me? It will be 2, 3. For carbon, atomic number 6. So it will be 2, 4. Very right. Yes. Nitrogen 7. So it will be 2, 5. Oxygen 8. It will be 2, 6. Fluorine, it is 9. So 2, 7. Right? And neon, it will be 2, 8. So we can clearly see that neon has got 8 electrons and the maximum capacity is 8 electrons. So we say that the octet for neon is complete. Octet is complete. It has complete 8 electrons. So the octet is complete or it is completely filled. Right? Similarly, for lithium, we can say that the duplet, because it can have a maximum of 2 electrons only. So the duplet is complete for helium. Likewise, we'll go for sodium. Can you tell me? K shell will have 2 electrons, L will have 8 electrons, and the remaining 1 electron will go to the M shell. So the configuration becomes 2, 8, 1 for sodium. What will it be for magnesium? It will be 2, 8, 2. Very right. What will be for aluminium? It will be 2, 8, 3. Good. Silicon, it will be 2, 8, 4. Phosphorus 2, 8, 5. Sulfur, it will be 2, 8, 6. Chlorine, it will be 2, 8, 7. Argon, it will be 2, 8, 8. Again, we can see that in case of argon, the octet is complete. So its K shell has maximum 2 electrons, L shell has maximum of 8 electrons, and M shell also has a maximum of 8 electrons. So the octet is complete for argon as well as neon, and for helium the duplet is complete, right? Now potassium, potassium, it has 19 electrons, so 2 and 8, 10, 10 and 8, 18, and the remaining 1 electron will go to the N shell, right? So 1 electron will go to the N shell. And what about calcium? It will be 2, 8, 10, 18 and 2, 20, right? So we can make another column over here. So what is the number of now the valence electrons? the valence electrons. So what are the valence electrons? Valence electrons are the electrons in the outermost shell. So the outermost shell here, it contains only one electron. In helium, it contains two electrons. In case of lithium, again it is one electron. In case of beryllium, it is again two electron. In case of boron, it is three electron, valence electron. For carbon, we have four valence electrons. So we say that the element carbon, it is tetravalent. It is tetravalent means it has a valency 3. Similarly, valency 4, right? And similarly, boron, it is trivalent. It has a valency of 3. Beryllium is divalent, a valency of 2. And lithium is monovalent. Monovalent means it has a valency of 1, right? Now for nitrogen, it has 5 valence electrons. So what is the valency for nitrogen? Can it lose this 5 valence electrons? No, it is not possible for nitrogen to lose this 5 valence electrons. So what it will do, it will gain 3 more electrons to complete the octet. So what you are going to do, you are going to subtract this 5 electrons from 8. So it requires 3 more electrons. So the valency for nitrogen is 3, not 5. Similarly for oxygen, it will be 8 minus 6, that is 2. So the valency is 2. For fluorine, 8 minus 7, the valency is 1. And for neon, 8 minus 8. So the valency is 0. It is a noble gas, right? It has a valency of 0. It does not take part in chemical reactions, right? Now for sodium is monovalent. It has a valency 1. Magnesium, it is divalent, right? It has a valency 2. Aluminium, it is trivalent. It has a valency 3. Silicon is again tetravalent. It has a valency 4. What about phosphorus? Phosphorus, it shows a valency of 3 and 5 also. And sulfur, it shows a valency of 2 and 4 and 6 also. Sulfur and phosphorus, it shows 2 valencies, 3 and 5. But by this calculation, you will say that the valency is 3 and the valency is 2 for sulfur, 3 for phosphorus. For chlorine, it is monovalent, the valency is 1 for chlorine. And argon, the octet is complete, so the valency is again 0 for argon, right? Yes, got it? I hope it is clear to you, right? Now potassium, again it is monovalent with valency 1, and calcium it is divalent with valency of 2, right? So this table is for the first 20 elements, right? First 20 elements, right? So this is the table for first 20 elements, right? So students, this table is very important. If you are studying chemistry, if you want to do good in chemistry, this table of first 20 elements, it is very important. If you are through with this table, you can do very much good in chemistry and you can score really good marks, right? So let me have a recap. First 20 elements table. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium, right? Here there are the names and symbols, right, and electronic configurations, right? And here is the number of valence electrons. In fact, what I have done, I have calculated the valency over here. So we can say that we have calculated the valency, from the number of valence electrons. So valence electrons are the electrons in the outermost shell. Actually, these are the valence electrons. These are the valence electrons. Valence electrons are electrons present in the outermost shell, right? So you can make another table if you want for valence electrons, right? Valence electrons. So the valence electron was 1, 2, then 1, 2, then 3, then 4, then 5, then 6, 7, and 8. Then again 1, 2, 3, 4, 5, 6, 7, 8, 1 and 2. But these are the valence electrons. These are the valence electrons which are the electrons present in the outermost shell. But this we have calculated the valency. Valency, it is the number of atoms which take part in a chemical number of electrons which take part in a chemical reaction actually, right? So this is the valency and electronic configuration. So this table is very very important. You hope you have understood this. Hope you will practice this well. Thank you. Have a good day.